In Lesson 1-6, you will learn about relations. You will also interpret graphs of relations. A set of ordered pairs is called a relation. A relation can be depicted in several different ways. An equation can represent a relation as well as graphs, tables, and mappings. The x values of a relation are members of what's called the domain. So that's the x numbers are the domain, and the y values are the range. The way I keep these two straight is I just think alphabetical, x, y, domain, range. Domain comes before range in the alphabet, x comes before y. So the domain has to do with the x values, and the range has to do with the y values of a relation. In our first example, we're going to express this relation as a table, a graph, and a mapping. We're going to start out by making the table. When you make the table, it's the x values and the y values. So we're going to go ahead and just put all of these ordered pairs into the table. 2, 5, negative 2, 3, 5, negative 2, and negative 1, negative 2. Now the next way we're going to express the relation is as a graph. We're going to take all of these ordered pairs and plot them on the graph. Remember, the first number tells us whether we move right or left on the graph, and the second number tells us our up and down or down movement. I like to think of it as you walk to an elevator and then you choose to go up or down. So the first ordered pair, 2, 5, means I'm going to go to the right 2 and up 5, since they were both positive numbers. Negative 2, 3, I'm going to go to the left 2 since it's negative 2, and then go up 3 since it's positive 3. 5, negative 2, I'm going to go to the right 5 and then down 2. And then negative 1, negative 2 is going to go to the left 1 and down 2 since they're both negative. Now the mapping just takes our domain and range and draws arrows matching up each domain with its range, corresponding range. So let's go ahead and label this domain. And this one range. We're going to go ahead and put in our domain numbers. Two, negative 2, 5, and negative 1. Now positive 2 matches up with 5. So we draw an arrow pointing to a 5 over here. And then negative 2 matches up with 3. 5 matches up with negative 2. And then negative 1 also matches up with negative 2. So we're not going to write negative 2 again here. We're going to go ahead and just draw an arrow to the same negative 2. Now the last question is to determine the domain and range of the relation. The domain, remember, is the x values. And the way you write the answer for the domain is in these brackets. You're going to list all of these. and then the range is going to be the y values. It's going to be these numbers right here, but the -2 we're only going to list once, just like we did over here in our mapping. So 5, 3, and -2. In a relation, the value of the variable that determines the output is called the independent variable, and the variable with a value that is dependent on the value of the independent variable is called the dependent variable, because it depends on the other one. The domain contains values of the independent variable, and the range contains the values of the dependent variable. In example 2, it asks you to identify the independent and dependent variables for each relation. In part A, it says the dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend on decorations. So we want to ask ourselves, what depends on what here? The more tickets they sell, the greater amount of money they can spend on decorations. So the decorations depends on the amount of tickets. So that means the tickets sold is going to be the independent variable. And then the dependent variable is the amount they spend on decorations. This is pretty sloppy. I should have used the keyboard, I think, instead of this mouse. In part B, it says generally the average price of going to the movies has steadily increased over time. So we have the price of movies and time as our two variables. Does time depend on price of movies, or does the price of going to the movies depend on time? The price of going to the movies depends on time. So time is our independent variable. The dependent variable would be the price of going to the movies. Our last type of example is looking at graphs and analyzing what is going on. The graph represents the distance Francesca has ridden on her bike. Describe what happens in the graph. Well, if you look at the graph here, this spot right here would show a time when they stopped. So as time went on, they started out moving and then they stopped for a bit because the distance did not change during this flat part, and then they started again. Looking down at this example here, driving to school, we have time along the bottom, distance on the side. As time went on, in the very beginning, it looks like they were driving really fast because they got a far distance in a short amount of time. And then it looks like there were two points where they stopped briefly, And the rest of the time they drove at maybe the speed limit instead of speeding like they did in this first part. And then this last example, change in income. This appears to be a pretty, the income is increasing as time goes on, with a little bit of a bump right here where it's gone up a little bit more quickly. But basically overall the income is going up, but it's not quite at a constant rate. If it were going up at a constant rate, you would have to see a straight line, and this isn't a straight line. It's got a little bit of a bump in it. So while it is going up as time goes on, it's not at a constant rate.